50% of the teacher's desk is covered in students' exams. What is the probability of spilling coffee on one of them? Half and half. You get it? Because you put half and half cream in coffee, and the probability is 50%, which is half. Okay, too much explaining. So now we're going to go ahead and use some of the things we've learned, in particular with the area, to model probability. And when you first learned about probability in middle school, you were primarily working with spinners. And I would show this spinner to my sixth graders, and I'd say, which of these outcomes is most likely? Well, you're going to find out that the areas all look the same, right? So the doll area is the same as the car area is the same as the teddy bear area. So there's no reason to think that you're more likely to win one over the other. So they're equally likely. Then, what is the probability that a child will win a teddy bear if all the areas on the spinner are actually equivalent? Well, since they're all equally likely, it's just 1 out of 3. Then I would, I'm going to show a different spinner, and I would show this kind of spinner to my sixth grade. And I'd say, Mrs. Overman, I'm using the spinner here for my class. First of all, how is this spinner different from the birthday spinner? Well, you can see that not all the areas are the same size, right? So you might guess that I'm probably trying to give something away more often than something else. What would you think I was trying to give away more often? Well, the Jolly Rancher area looks bigger. Maybe I want them to land on that more than I want them to land on Cheetos. Probably because Jolly Ranchers cost less than Cheetos. So, not all sections are the same size. And what is the probability that a student will win the Jolly Rancher? Well, when I first did this question for my sixth graders, and I would give them a spinner kind of like this, it's a 1/3 because there are 3 outcomes. But the outcomes don't have the same size. They don't have the same percentages. So what I would do to help them out, since they hadn't really done much on area yet, is I would just draw a line right here, and you can see that in reality there are 4 equal sections there, and Jolly Ranchers have 2 sections out of 4. So it's really 1/2. And the reason it is, I did the line for my sixth graders, but most of the time as adults we can see, oh, Jolly Ranchers take up half the spinner, so it's half of the probability. So the probability of an event is the fraction or percentage of the time we expect it to happen. If I expect it to happen half the time, the probability is 1/2. If I expect 1/4 of the time, it's 1/4. Now we use the area model. We can generalize geometric probability to the area for the event over the total area, which is nice because then it lets us look at probabilities where there are different percentages for the different outcomes. In this example, I want to know what is the probability if I randomly choose a point in the square there that it's going to be in the semicircle. So first of all, let's start off with our probability idea. The probability that something's in the semicircle, and oftentimes we'll say P with parentheses and the event in there, equals the area of the event, the semicircle, over the total area. So first of all, let's find the area of the semicircle. That's going to be 1/2 a circle, or 1/2 pi r squared. You can probably tell that the radius here is going to be 1/2 of the 8 inches, so it's 4. Substitute that in, 1/2 pi times 4 squared. 4 squared is 16. 1/2 of 16 is 8. So it's 8 pi. I also still need to find the total area, which is just the square. So the area of the square is 8 squared, or 64. Now I'm going to substitute both these values back into this formula and say the probability of getting a semicircle is 8 pi over 64. That simplifies to pi over 8. And if I grab my handy-dandy calculator and put that in, I get approximately 0.39 or 39 hundredths. So for some further reflection, what does it mean to find the probability of an event? And in our problem, both spinners had 3 outcomes. Why were the probabilities different, even though they each had 3 sections? And based on the ratio for probability, in other words, that it's the area of the event over the total area, what do you think the maximum value, what is the most that number could be? And also, what do you think the least that number could be?